Hey gang, we're looking at an 802.11 BG global parameter configuration here in a Cisco wireless LAN controller. The reason why is because I want to ask you some questions about what we're seeing and what are some of the effects that making changes in this configuration might have. So first, let me ask you, why is it that if we look over here, that there are multiple data rates that are either supported or mandatory or they even can be disabled? Why is it that we support more than just one data rate? And specifically, why would we need to have more than one mandatory data rate? Pause, and then we'll talk about the answer. Well, gang, if we've got an access point and it's radiating out that signal, if we have a device that's very close to that access point, then we can focus on speed. And so we might use one of those speed values that are shared between the two that would enable us to have the best performance. But as we get farther away and our signal is more tenuous, our focus changes to being less on speed and more on guaranteeing that the data gets there. Remember that air moves the same speed. Our ability to send wireless signals, they all move the same speed. So what's really changing to get me better bandwidth? I'm putting more data into each frame that I'm sending over the wireless network. So that's why we have multiple frame rates, is to allow for us to have, let's say, 11 megabits per second with 802.11b if I'm up close, and maybe as little as 2 or even 1 as I move farther away. Okay, so we've said that. Now, next question. Why is it that all of these higher data rates are supported but not mandatory? Pause, and then we'll talk about the answer. Well, gang, in this configuration, you'll notice that this is the BG configuration with 802.11g support enabled. So with G support enabled, what does that mean? It means that I'm supporting B, which works our way up to 11, but then I'd like to add all the supporting algorithms that are available to encode using OFDM, right? The newer technique as opposed to DSSS, which means that we can go to faster speeds with DSSS. So why are these supported? Well, because if I have a B client, right, he's going to have to work in this range. I can't make them mandatory because only the G devices can work up in that particular range. Okay. Gang, here's a tough question. What is the encoding technique called for our 1, 2, 5.5, and 11 megabit per second DSSS configurations? What do we call those encoding techniques? See if you can track down that answer, and then we'll talk about it together. Pause for just a second. Okay, so we're talking at the earliest levels about using the original Barker encoding mechanism, which is done through frequency modulation. So what we're going to be doing here is using dBPSK. Then at the 2 megabits per second, we move to dQPSK, so we move from binary to quad. Then we move to the the complementary code keying, CCK, and that's what's used both there and there, right? Just different forms of it. All of these other supported options are available through OFDM. So now, what is the difference between the way that we modulate in DSSS versus the way that we modulate in OFDM? What are we changing to encode our message differently? Pause, look at that answer, and then we'll go over it together. Okay, so when we are using DSSS, we use what is known as frequency modulation. But when we are working with OFDM, we're going to use amplitude modulation. So that's where we're using BPSK, QPSK, 16-QAM or 64-QAM or even 256-QAM, powerful mechanisms of encoding content in using orthogonal frequency division multiplexing. All right. Thanks for going over this together with me. Hopefully this will help some of this information to stick for you.